In this lesson, I'll show you how to find the absolute maximum, minimum for a multivariate function using partial derivatives. This is question 1. The question reads, find the absolute maximum, minimum of the function f at xy is equal to 2x squared minus xy plus 3y on the region where x is greater or equal to 0 but less than or equal to 1 and y being greater or equal to 0 but less than or equal to 1. The first thing that I want to do is show you a visual of the region in which we have to focus finding the absolute maximum or minimum. And the way I'll do that is I'll use a Cartesian plane, an xy plane, and draw out this region. 0 to 1 will represent a line from here to here, and 0 to 1 in the y coordinate will represent a line that extends from 0 all the way to 1. So this is 0, that's a 1, and so what we've formed here is a square. We have a region here which I'll call L1, L2, L3, and L4. The next thing that you want to do is find the critical points for this function. And we learned in previous videos where we found the local minimum maximum that you can find the critical points by finding the partial derivative with respect to x and y and setting that equal to 0. That will give you a system of equations which you can solve simultaneously. So let's go ahead and do that. We have f sub x, the partial derivative with respect to x. This first term is 4x. This next term will hold y as a constant, and taking the derivative of x becomes 1. So we have negative y. And 3y is a constant if we're taking the partial derivative with respect to x. So this all becomes 0. And eventually we'll set this equal to 0. The partial derivative with respect to y will look like this. If that term becomes 0, this term becomes negative x, because this time we're holding x constant, and this becomes plus 3. We'll set that equal to 0 as well. So now we have a pretty simple system of equations to solve. In fact, all you do is you take this plus 3 over, then you have negative x is equal to 3, divide both sides by negative, x is equal to 3. Substitute 3 into here, 4 times 3 is 12, 12 minus y is equal to 0, bring the y over, you have 12 is equal to y. So your critical point is at 3 and 12. Now notice what they've given us here. They've told us that the region is bound within this box, except our critical point, 3 and 12, is outside of this box. Therefore, we cannot use this critical point to find the absolute maximum or minimum. Instead, what we have to do is analyze what happens along this line, this line, this line, and this line individually. If you're confused by that, here's what I mean. Let's start by analyzing what happens along L1. So our function will be evaluated. Since we don't know the precise x, because it ranges from 0 to 1, we'll write down x, but we do know the y, it's 0. So we'll evaluate this at x and 0. So we'll substitute x wherever we see an x. We have 2x squared minus x times 0 plus 3 times 0. This reduces down to 2x squared. At this point, what you will do is evaluate this function at your lower and upper bound. So your lower bound is x and your upper bound is 1. So at x is equal to 0 and x is equal to 1. If we evaluate this at 0, we'll end up with 0. And if we evaluate this at 1, we end up with 2. So our local minimum here is 0 and our local maximum is 2. So our maximum along this line is 2. That's our max. And subsequently, the minimum is 0. Now we have to do this for L2, L3, and L4. And then eventually, once we have all of the numbers, we can choose which one will be the minimum and which one will be the maximum. Let's move on to L2. So this was L1. L2 will be something very similar, except this time we'll evaluate the function at x being equal to 1 and y we don't know. The function we started with was 2x squared minus xy plus 3y. Substituting 1 and y where we see an x and a y respectively. 2 times 1 squared minus 1 times y plus 3 times y. This leads us to this becoming 2 minus y plus 3y. We can combine this term and this term. We get 2 plus 2y. That was easy, and now we will evaluate this where y is equal to 0 and y is equal to 1. Because take a look. It ranges from 0 to 1. Substituting 0 into here gives us a 2. And substituting a 1 into here gives us a 4. So this is our maximum, and this is our minimum. Let's do along L3. L3 is from x being equal to 0 to 1 and y is equal to 1. We use the exact same function we started with. 2x squared minus xy plus 3y. And we will evaluate this where we don't know the precise x, but we do know the precise y. Substituting x, we have 2x squared minus x times 1, which is x, plus 3. Because substituting 1 into y is 3 times 1. At this point, we're supposed to evaluate this function when x is equal to 0 and x is equal to 1. But since this specific function is a quadratic, the function itself has critical points. And we can find the critical points by using the closed interval method. In that, you will find what the derivative of this function is. Let's call this function f at x. And the derivative is 2 times 2, which is 4x. That becomes minus 1, and that becomes 0. Setting this equal to 0, we're kind of finding the critical points here. We have 4x is equal to 1, and x is equal to a quarter. So not only are we going to evaluate this at 0 and 1, we're also going to evaluate it at x is equal to a quarter. Let's see what happens if we do this. If I substitute 0, this becomes 0, that becomes 0, we end up with an output of 3. Substituting 1, 2 minus 1 is 1, plus 3, that's 4. And substituting a quarter, let's use our calculator. 2 times 0.25 to the power of 2 minus 0.25 plus 3. We end up with approximately 2.875. 2.875. This will be our minimum, and this will be our maximum. Let's write that down. Max and min. Finally, along L4. Remember the function we started with was 2x squared minus x, y plus 3y. L4 has an unknown y but a known x. The x is at 0 and the y is unknown. Let's substitute 0 into here. That becomes nothing, that becomes nothing, and this becomes 3y. We need to now substitute y is equal to 0 and y is equal to 1. Substituting y is equal to 0 gives you 0, and substituting 1 gives you 3. That's your min, and that's your max. So if you look at L1 through L4, your maximum was 4, and your minimum was 0. Therefore, the absolute maximum is 4, and the absolute minimum is 0. If you'd like to see another example pertaining to absolute maximum and minimum, make sure you watch question 2 of this series, which follows this one. We'll see you soon.